Today's lesson, we're going to talk about measuring and constructing segments. But before we do that, we need to introduce some vocabulary that you may or may not have heard before. In geometry, a rule that is accepted without proof is called a postulate. Okay? You might also hear the word axiom. They mean the same thing. It's just something that we accept as true. Nobody argues it. We just say, yes, that's right. Okay, something that we have to prove, a rule that can't be proved, is called a theorem. All right, so the first thing I'm going to introduce to you is what's called the ruler postulate. Before we do that, I kind of have to lay some background and kind of tell you where this postulate comes from. And the idea behind it is that I take a line, or the points on a line, and I match them with a one-to-one correspondence with the real numbers. So basically, how we draw this is we see a line, right? And if you remember the number line, we designate these little distances here, right? And then we might have like 0 here, so we'll have a -1 here, -2, 1, 2, 3, kind of this kind of idea where we kind of map out and divide up the number line. Okay. The real number that corresponds to a point, so if I put a point here, this 0 right here would be the coordinate of this point. Okay. In the general sense, though, just kind of speaking in general terms, I might call this like x1, and I might have a point over here, and we could call that x sub, I don't know, we call it 2. Okay. So we're labeling these distances, or these segments. Okay, and we're calling them, and we're giving them some value off of the real number system, and we're able to actually measure the distances between the different points. So we have now what we're going to define as the distance, the ruler postulate, how we measure this, the distance between points A and B, written as this capital AB here without any kind of bar on top. It's just the two capital letters put together, is the absolute value of the difference of the coordinates of A and B. All right, so let me draw this. If I have my line, and I pick these points A, put A on top, put A here, and put this point here, B. Okay. If I want to measure this distance, I have to go to my coordinates and say this would be x sub 1 and this would be x sub 2. And so to get this distance, what I do is I take the absolute value of my coordinates. So this would be x sub 2 minus x sub 1. That's going to give me the distance from A to B. Okay. So anytime you see this without the bar on top, that's talking to you about, or that's telling you that you want the distance from A to B. So this distance from here to here, that's the length of AB. All right, so let's look at this first example. It says find the length of segment BE. And so this would be B and this would be E. All right, and so when I'm looking at length, remember that we said that I take the absolute value of the coordinates, the difference of the absolute value. So that would be 5 minus a -1. Okay, which is going to be equal to the absolute value of 5 plus 1, which would just be 6. Okay? And I know for a simple problem like this, basic problem, you can't just count the units. You just go 1, 2, 3, 4, 5, 6, and that would give you the distance. But there are problems that get a little more complicated, and it's not just a matter of counting down the number line. So what you want to do is you want to subtract the difference between the two coordinates and take the absolute value. Those of you that don't remember about absolute value, remember absolute value is always positive. So if I were to get something like, say I had -3 plus 1, and I want to take the absolute value of that, when I subtract these two or add these two, -3 plus 1, I get -2. But because I have these absolute value bars on it, I flip it or change the sign and it becomes positive. All right, next we have what's called the segment addition postulate, and that says that if B is between, the point B is between points A and C, then the distance from A to B plus the distance from B to C is equal to the distance from A to C. So let's draw this real quick. If I have a segment, okay, and let's see, B is between. So here's A, here's C, and B is somewhere in between. What this is telling us that I can take this piece and add it to this little piece to get the entire segment. Okay, so this distance here, the distance from here to here, we would call that, or we would say that that's the distance AB. Right? And then the distance from here to here, that would be this length BC. Okay. I can add those two together to get this whole length right here. All right, now let's look at some examples of this segment addition postulate. And what it says, or what we have to do then, is find the distance of this segment DF, or the length from here to here. So because I know DE is 23 and EF is 35, I can add those two together to get the entire length. All right, so the segment addition postulate says that I could take DE, add it to EF, and I would get DF. If I substitute these values in, that tells me that 23 plus 35 is going to give me this length DF, which is going to be 23 plus 35 would be 58. Okay, so the distance from D to F is 58 units. Okay. Now looking at this part B here, it says find GH. GH is here. There's not a number here. It's part of this whole segment FH. Okay, so this would be kind of my X, what I'm looking for. All right, well, I know that FG, the distance from F to G plus GH, that's going to give me the entire length. Okay, so looking at this algebraically, that tells me that's 21 plus X, which has to be 36. Okay, so what I'd have to do then is I know this piece and I know the whole thing. So I'm going to have to subtract the 21 minus the 36. So that goes to 0, X comes down. 36 minus 21 is 15. So that tells me that the distance from G to H is 15 units. Okay. If you don't set it up algebraically using these symbols, you just have to remember or realize that I have the total length and I have part of the length, so I have to subtract these two numbers to find out what's missing. Now we have to use what's called the distance formula, and the distance formula is what's happening when we move a segment from a regular line, like one-dimensional number line type problem, and we put it on a coordinate plane where there's the x and the y axis. And so that changes the formula or the way of thinking about the length of the distance of a segment, or the distance between 2 points. So we start by letting A be at x1, y1, and if B is at x2, y2, then the distance of A and B is this formula here. Now, this formula comes from just simply looking at a coordinate plane where you have x and y axis. All right, and then you pick a place for A, right, and you would say that that location is at x1, y1. And then you have some point somewhere up here, and we'll call this one B. And the coordinates of B would be x2, y2, just some numbers there. Right, and you want to calculate the length here from these two. All right, well, on the coordinate grid, what you can do is you can actually go, okay, I can go across this way, and I can measure that length there horizontally, and then I can come up from there, I can come up this direction, and I count those units. And so I have a right triangle. So what ends up happening, the way they discovered this, is we use Pythagorean theorem to kind of come up with this formula, right? And so the formula, the distance from A to B, ends up being the square root of x2 minus x1 squared plus y2 minus y1 squared. So now example 3, we're going to use the distance formula. It says your school is 4 miles east and 1 mile south of your apartment. A recycling center is 2 miles east and 3 miles north of your apartment. And it wants to estimate the distance between the recycling center and your school. Okay, so the easiest way to do this, or the best way to do this, is to go ahead and put it on a coordinate plane. Right, so we would say This is our x-axis, this is our y-axis. And the easiest way to set this up is to go ahead and set your apartment, since everything's kind of related, or in terms of where they are from the apartment. It's easiest or best to put the apartment at 0, 0. Okay, so that's where the apartment is. And the school then is going to be 4 miles east, which means you go 4 units to the right, and 1 mile south, so you're going to go down 1 this way. So that coordinate would be 4, negative 1. And then the recycling center is going to be 2 miles east and 3 miles north. So the coordinate of that is 2, 3. And they want the distance between those two. To do this, remember that we need an x1 and y1, and we need an x2, y2. All right, so if it helps to label these, you can. You'd say x1, y1, and this would be x2, y2. Okay, and so to stick this in the formula, the distance is equal to the square root of x2, which is 2, minus x1, which is 4, squared, plus y2, which is 3, minus y1, which is a negative 1, squared. Okay? Now it does say estimate, so we can actually put this in the calculator. And so putting it in the calculator, we get the distance is about 4.5 units. Now I have to introduce what's called congruent segments. And basically all that means is that line segments that have the same length. There is a symbol for congruent, and that is this. Okay, the equal sign with the little wave or tilde on top. Right? And so you would say that, let's say segment AB is congruent to segment, I don't know, we'll call this DC. Okay. And so what looking at this statement tells you that the distance from A to B is equal to the distance from D to C. In other words, two segments are congruent if they have the same length. So in other words, just notation-wise, how you read this, you'd say segment AB is congruent to segment DC. Okay? When you get that statement, that tells you that the distance or the length from A to B is equal to the distance from D to C.